Now we go to number 4. Number 4, it said that we have 3 geometric progression PQR such that the sums negative. Okay. Find the sum of the progression of R. Okay. Mm, okay, so it said that the sum to infinity of the first 3 terms is arithmetic progression. So okay, we find first the sum infinity of the P is equals to U1 2 over 1 minus the ratio is half. So here we shall have 4 for the sum to infinity of P. And then sum to infinity of Q, the U1 is 3 over 1, and then the ratio is divided by 3, so 1 over 3. So we have 3 over 2, 3. So we can write down this is 9 over 2. So we have 4 and then 9 over 2, or we can write down this is actually 4.5. So if the arithmetic, so the next one, the difference from 4 become 4.5, it is plus 0.5. So the next one should be 5. Because if we plus with 0.5, we shall got 5. So the I, it is 5. Okay, now we go to the II. Given the first term of R is 4, find the sum of the first 3 terms. So we know that this is the sum to infinity of R. So sum to infinity of R, it is 5. And then we input the formula. So the first term, it is 4. So 4 over 1 minus R equals to 5. We find the R first. So this is cross multiply. So become 4 equals to 5 times 1 minus R. Remove the 5. So we got 4 over 5 equals to 1 minus R. So R equals to 1 over 5. So the ratio is 1 over 5. And then it asks us to find the sum of the first 3 terms. So the sum of the first 3 terms. So I think we can use directly the first S3, sum of the first 3 terms. So S3 equals to the U1, it is 4. So 4 times 1 minus, the ratio is 1 over 5, the power of 3, over 1 minus 1 over 5. So if we calculate it, we shall get the S3, it is, if think I will make it into decimal. Okay, I got 4.96, the S3, 4.96. Okay, that is for II, number 4. Now we go to number 5. Number 5, it does us to show that this. So I will start doing from the left to show to the right. So sine about 4 theta minus cos about 4 theta. I have to make it into sine. So I think this cos later I will make it become sine. So first I will split it first. So this is sine squared theta minus cos squared theta times sine squared theta plus cos squared theta. And then this cos square we may become sine square. So sine square theta minus 1 minus sine square theta. Sine square plus cos square, it is 1. Then here we have sine square minus sine square. So 2 sine square theta minus 1. So it's proof for the I. And then for the I solve the equation this. Okay. So usually for the I and I for this equation, they are related each other. So I will not start from sine to the power 4 minus cos to the power 4. I will directly change it become 2 sine square minus 1. So 2 sine square theta minus 1 equals to half. Okay, if I move the minus 1, so 2 sine square theta equals to 3 over 2. And then I move the 2 becomes sine square theta equals to 3 over 4. And here we shall get two things sine theta equals to positive 1 square root 3 over 4. And then the other one is sine theta equals to minus square root 3 over 4. Or 1 over 2 times square root 3. Okay, so the theta will be 1 over 2 square root 3. So it is 60 degree. And then this is for the quadrant 1. So for the quadrant 2, it should be 180 degree minus 60 degree. So it should be 120 degree. And then this also the same value, but this is minus, so it's in the quadrant 3 and quadrant 4. So for the quadrant 3, it should be 180 degree plus 60 degree. So it's 240 degree. And then for the other one, it is theta equals to 360 degree in the quadrant 4 minus 60 degree. So it should be 300 degree. So that is for number 5 II. Now we go to number 6. Number 6a is the point of this, b is the point of this. Find in terms of a the gradient of a line perpendicular to AB. So remember, whenever we hear about perpendicular, so we have to do gradient. So the gradient of AB, it is equals to, okay, this should be 2a minus 1 minus with by 2 minus 1, so 3a plus 9 over, and then we have a minus 2a plus 4. Okay, so this should be the gradient 2 minus 3a, so minus a, minus 1 minus 9, so minus 10, over a minus 2a, so minus a, and then we have minus 4. And then after this, to find the gradient of the perpendicular, so we know that the gradient of AB times the gradient of the perpendicular equals to minus 1. The gradient of AB, it is minus a minus 10 over minus a minus 4. The gradient of B equals to the perpendicular equals to minus 1. And then this, the gradient of the perpendicular is minus 1 times width. So we flip it. So it becomes minus a minus 4 over minus a minus 10. Okay, if I want to simplify it, become equals to minus a minus 4 over a plus 10. Okay, so that is for 6i. And then for the 6i, it say given the distance AB is this, find the possible value of A. Okay, so we use the distance formula of AB. So AB distance is square root 260. So square root 260 equals to the distance square root of x minus this. So it is a minus 2a minus 4 square plus with then 2a minus 1. And this we minus with this. So minus 3a minus 9 square. And then both square root we can cancel it. So we got 260 equals to a minus 2a. So minus a minus 4 square plus with 2a minus 3a minus a minus 1 minus 9. So is minus 10 square. Okay, here we got this. Okay, and then we do the expansion. So 260 equals to a square 2 times this. So it is plus 8a plus 16 plus with, then we expand this a square 2 times this 20a plus 20a plus 100. Okay, this 260 I will move to the other side. So I will got 0 equals to a square plus a square. It is 2a square. 8a plus 20a, so plus 28a. 16. 16 plus 100 and then minus with 260. So minus 144. And then we can simplify everything divided by 2. So becomes 0 equals to a squared plus 14a minus 72. So the a, we can get a here minus 4 times a plus 18 equals to 0. So we have a equals to 4, a equals to negative 18. So that is for number 6. Okay, for number 7, it is about the factor. Because it's not included into the syllabus, so I will skip number 7. Now I will go to number 8. We have a curve fx. The stationary point is this, in such that the second derivative is this. State the reason whether this stationary point is a maximum or minimum. So to find this, we just directly substitute the x value, use 3. So second derivative, 36 times the x is 3, the power negative 3. So we have 36, 3 the power of 3. So per 27. So it is positive. So a positive value, the nature or it should be minimum point. So, okay. And then there's just to find the first derivative and the original function. So, okay, let me. So we integrate this to find the first derivative. Integrate 36 x to the power minus 3 dx. So this will become 36 x to the power negative 2, or this is negative 2 plus c. And then this negative 18. And then it say what? The stationary point. So the gradient is 0 equals to negative 18. The x is 3. So 3 to the power negative 2 plus c. So we find the c, it will be This remove become positive. So 18 times 1 over 9. Or we call this is 2. So the first derivative, it will become negative 18x to the power negative 2 plus 2. Okay, and then we find the fx. We integrate it again, so integrate minus 18x to the power negative 2 plus 2 dx. So this will become minus 18x to the power negative 1 over negative 1 plus 2x plus c fx. And then we input the value 3, 7. The fx is 7. 7 equals to minus, wait, minus, so become positive. So 18, the x is 3. So 3 to the power negative 1 plus 2 times 3 plus c. So 7 equals to 1 over 3. So it's 6 plus 6 plus c. Or 1. So c equals to negative 1. So the fx should be 18x to the power negative 1 plus 2x minus 5. So that is for number 8. Now we go to number 9.